Welcome back. We're still on lesson 4.11 and we almost got off the hook of this, but we are going to review rounding really quickly. I want you to write round to the nearest dot 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 and put a little star in front of it. Ready? We're going to say round to the nearest. Let's make like a little chart actually. Going from one of the pink lines, red lines, to the other. And it's 5 lines wide. And make that green. Okay. We're going to round these numbers that we put over here to the nearest tens, to the nearest whole number, which would be the ones. And we're going to practice rounding to the nearest tenths and hundredths. Maybe we better do 100 and then tenths and hundredths. Actually, let's do hundredths. We're going to kind of mix it up a little bit so it's not in this perfect order. And then tenths at the very end. So I'm going to separate those out with yellow. We're going to be rounding a number to the nearest tens, a number to the nearest whole, a different number to the nearest hundreds, and then we're going to be rounding some numbers to the hundredths and tenths. Not the same number. We're going to pick a different number every time. Okay? And then the quick steps, remember, are to underline the place value. Look to the right. When you look to the right, you're going to do that phrase. 5 or more, raise the score. 4 or less, let it rest. Make necessary changes is the next step. And end in the place value they asked for. Lots of little quick steps. Underline the place value, look to the right, ask yourself 5 or more, raise the score, 4 or less, let it rest, make the necessary changes, and then end in the place value they asked for. You ready? We're going to round this number to the nearest tens. $89. Well, which number's in the tens? You're supposed to underline it. Let's use yellow. And use your pencil to look to the right. What does the 9 tell the 8 to do? Raise the score. So the 8 changes to a 9. This is the changes we're talking about. Do you just leave it? Everything else disappears? No, not when it's whole numbers. You have to put zeros in the extra place values. So, did we end in the tens? Like, are all the digits filled? And everything after the tens zeros? Yes, so circle the final answer. 89 rounded to the nearest tens is 90. Now let's round a number to the nearest whole. You ready? 13.209. If I'm asking for the nearest whole, again the number is 13.209. You need to underline the place value. Which place value is the whole number? It's the 3. So you look over to the next number to the right. What does that 2 tell the 3 to do? If you said let it rest, you're right. So the 3 stays. These are the necessary changes. What happens to that 1 in front of it? It stays. Everything in front has to stay. Everything behind it either changes to zeros or disappears. So we have a decimal, which means it can just disappear. If you want, you could put 0.000, but you don't need to. 13 is the final answer. You need to circle it. So 13.209 rounded to the nearest whole number is 13. Because it's closer to 13 than it would be to what? To 14. Remember, that's how you do this. 89 was closer to 90 than it was to 80. Okay, now we're going to round a number to the nearest hundreds. It's going to be a pretty big number. 17,463. Yeah, 17,463. Rounded to the nearest hundreds. Let's underline the digit that's in the hundreds. You should have underlined the 4. Okay. So now I look to the right. The 6 tells the 4 to raise the score. So 4 changes to a 5. Everything else stays the same in front of it. Even the comma. And what happens to the numbers behind it? That's right. They change to zeros. The answer is 17,500. Okay, we're going to round a number to the nearest hundredths now. So, if we're rounding to the nearest hundredths, then we have to have a number that at least goes into the thousandths, right? Let's try 1.092. We're going to round 1.092 to the nearest hundredth. So underline the 9 that's in the hundredths. Make sure you draw an arrow over to the 2. The 2 tells the 9 to let it rest. Everything in front's the same. Everything behind it disappears or changes to a 0. 1.09. And the last one, rounding to the nearest tenths. .97, rounded to the nearest tenths. Which digit is in the tenths place? Underline it in yellow. So the 9 is in the tenths place, and it looks over at the 7. And the 7 tells the 9 to raise the score. How do you change a 9? Oh, it changes to a 10, right? So you have to put the 0, because only one digit can fit in each place value. So you put the 0 and you carry the 1. And now 2 and 1 make 3. The decimal has to stay. So yeah, 2.97 rounded to the nearest tenths actually changed the whole, the ones place, and the tenths place. But you don't need any of the other digits. So 2.97 is closer to 3.0 than it was closer to 2.9. That's how that works. So now that we remember how to use rounding, why are we even talking about this with multiplication? It's because we want to be able to use estimation to check our answers. That's the whole point. So right here, we're going to use rounding for estimation. Will you write that really big across the paper? And underline it in green. Use rounding for estimating. Use rounding for estimating. So we write estimate and exact. Do you remember us doing that? We just did it the other day in our journal. Estimate and exact. I'm going to just double check. Yeah, we just did it the last time. Estimated answer and exact answer. Estimate is going to be over here on the left. Exact is going to be over here on the right. Estimate will be yellow. Exact will be green. And also add yellow to the estimating line up there. Okay, so we do a problem like this. Let's do 1.8 times 5.2. So what would the estimate be if I'm using rounding? So use yellow. So it says this, in case you're having a hard time with that. It says 1.8 times 5.2 is an estimate of blank times blank. So we're going to use rounding real quick. What is 1.8 really close to? It's either closer to 1 or closer to 2. Closer to 2. And what is 5.2 really close to? Think about whole numbers. It's either closer to 5 or closer to 6. You always say the first number and then the next number up. So it's either closer to 5 or closer to 6. It's closer to 5. So my estimate should be 10. When I get my exact answer, it should be really close to what? To 10. Let's find the exact answer. 1.8 times 5.2. You have to do standard algorithm. Are there any zeros? No. Is the longer number on top? Doesn't matter. They're both 2 by 2. So you need a decimal box. Make it green. What number goes in the decimal box? It's a 2. And now it's like doing 18 times 52. So go ahead and do that standard algorithm. Make sure you use a 0 for place holding when you move on. Double check that you got the same partial products as me. Add them together. Wow, 936 is not close to 10. Oh, it's the decimal box. Should always be checking your answer and thinking about it. If I move the decimal 2 places to the left, it becomes 9.36. And 9.36 is really close to 10. So I did a little yellow arrow. I'm going to write really close. So that proves to me that my answer is probably right because I have an estimate that's really close to that. So that's what we do with rounding, is we use it to estimate, to make sure that what we're doing is correct. That's what we do with it. Okay? The last thing we're going to do, I just love this so much, is some real world problems. So we're going to write that at the bottom. Real world problems with an arrow. Actually, let's say situations. Some real world situations to the right. So we're going to turn the page. You need page 177 in your workbook. Has a toucan on it. It says Unit 4, Lesson 11, page 177. You ready for this? We will not be solving all of these problems. We're only going to be solving numbers 24, 25, and 26. So you'll need your pair of scissors out, and you'll need to cut out 24, 25, 26 as one big problem. And you're going to save the part we are not using, so be very, very careful. So save all the pieces that we're not using right now. But we're just looking at numbers 24, 25, and 26. Keep all of this space to the right of those problems because we're going to need space to solve all the problems. See how I cut it out like that? All right, keep out your green and yellow. That way we can highlight important things. Number 24, the 5th grade is getting a special lunch. Don't you wish that was true? The cafeteria manager is planning to buy 0.3 pound of turkey for each student. If turkey is on sale for 79 cents per pound, what will it cost to give turkey to 100 students? Whoa, we got a lot going on here, right? Think about it. I've got 3 numbers here. Let's highlight all of them in yellow. 0.3, 0.79, and 100. Each student is going to get 0.3 pound of turkey. How many students are they giving it to? 100. So why don't we find out how much turkey they need total and then times it by the pound. So let's go like this. Total turkey at the top. Total turkey is 0.3 times 100. Because each kid's going to get 0.3. And there's 100 kids. Guess what? This is not as hard as you might think. We're timesing by 100, which is a power of 10. What that is 0.3 times 10 to the second. 100 is 10 to the second. So I get to just move the decimal 2 times. If I move the decimal in 0.3 2 times, I need another 0. It equals 30. So they need a total of 30 pounds. And how much is it per pound? 79 cents. So now I'm doing 0.79 times 30. Okay. Is the longer number on top right now? Yes, there's a decimal involved, so I need a decimal box. You don't have to make it green. Actually, you do need to make it green. Okay, are there any zeros? Yeah, there's one out in front. That's a runt. See ya. And there's one at the end. It's a friend. And it goes straight down into my answer. Now it's just like doing, oh, sorry. Ooh, we didn't put a number in the decimal box. What number goes in there? It's a 2 because there's 2 place values after the decimal up here. Okay, whew, now we can do 79 times 3. Remember that 0 is part of the answer. 3 times 9 is 27. 3 times 7 is 21 plus 2 is 23. So it's 2,370. Can't be. It has to be a decimal. That makes sense. It's money. What will it cost to give turkey to 100 students? It will cost $23.70. It's pretty cheap, actually. I'm just going to end that there. Number 25. 1 gallon of water weighs 8.3 pounds. So highlight that yellow. About how much does 4.8 gallons weigh? So 1 gallon weighs this. How much does 4.8 gallons weigh? Oh, this is so easy. That's just quick multiplication. Why don't you try and solve this one all on your own? You can follow me quietly if you'd like, but otherwise it's good for you to practice and see if we get the same answer. Use your green for decimal box. Check to see if you got the same partial products. Don't forget the decimal box. Think about this for a minute. Is that a reasonable answer? Well, yeah. 4.8, right, rounds to about 5. I'm just going to put a 5 by it. And 8.3 rounds to 8. And if I multiply 8 and 5 together, it should be about 40. Maybe they wanted it because they said about with estimating. So I'll say it should be about 40. And is exactly 39.84 gallons. It's kind of cool. We did the estimating and the exact. All right, number 26 is a challenging one, and I love it. Anne read it costs 57.5 cents to drive a car a mile. Anne lives 0.6 miles from school. What does it cost her to drive to and from school every school day for a week? First of all, will you box every school day for a week? How many school days are there in a typical week? I know we only come to school 4 days right now, but most often we come to school 5 days a week, right? And Fridays still count as school. So it's 5. You need to not panic about that number. That number is 5. They're just making you think about it. So she lives 0.6 miles from school. She has to drive to and from. Underline that in green. To and from. So if she drives to school, it's 0.6 miles. What if she drives back home? It's another 0.6. Right? So we know this number down here is going to be 5. And we have to do 0.6 plus 0.6. We have to know how far she goes. I love solving problems like this. It's like being a detective. This is adding. We have to find out how far she goes in one day. This is the button man. Do you know the button man? The button man, the button man. Do you know the button man? He lines the decimals up. That's how far she goes. Circle that in yellow. Or highlight it. In a day, she'd have to go 1.2 miles. In one day. But how many days does she go for? She goes for 5. So guess what you have to do? You have to times 1.2 by 5. There's a decimal box. A 1 goes in the decimal box. Because of that, there's only one place value after. And do you know what 12 times 5 is? You should. It's 60. But there's a decimal box. So really, it's just 6. I'm not even done yet. I'm just highlighting that in yellow. So, my friends, she goes 1.2 miles every day. So in a week, she would go 6 miles. A week of school days. She would go 6 miles. 6.0. 6. But the question is, what does it cost her? That 57.5 is super important now because that's per mile and she goes 6 miles in a week. So you have to do 57.5 times 6. This is an awesome, challenging problem. So 57.5, actually I'm going to write that more over to the side. 57.5 times 6. Do you know what number goes in the decimal box? A 1. There's no zeros, so you just do 575 times 6. See if we get the same answer. Don't forget the decimal box. Oh, this is interesting. The way I set this up, whoop, stop, put your brakes in the car. The way I set this up is actually wrong. Because look, I got to the end, I went like, this is how I know this. I really hope you follow my pattern here. I love learning like this. By mistake, it's the best. Because look, I got to the end and went, okay, I'll move the decimal, and it's going to be 345.0. You think she doesn't even live a mile. Miss Fisher lives 20 miles away from school. And I drive that every day. So it cannot be $345. She barely lives a mile away. That's like down to the Maverick and back to Bluffdale. It can't be that. So I stopped in my tracks and I put on the brakes and I went, oh, something's wrong. And then I went, oh, maybe I got the decimal number wrong. Nope, I didn't get the decimal number wrong. Here's what I figured out. Did you figure it out before me? The number is represented right here as $57.50. 0.5 is 50 cents. You can't set it up like that. When you do cents, even though it says 57.5, it just means 57.5 of a cent. Whoa. So 57.5 of a cent. Yeah, I am going to erase all of this part. Do you know how that gets represented? It's pretty interesting. This 57.5% gets represented like this. 0.57, because that would be 57 cents. And what number represents a half, or how would I get a half of a cent? I would put a 5 in the thousandths place. So crazy. 57.5 cents is represented as 0.575. Ooh, that is hard. And now times that by 6. That decimal number is drastically different. It is a 3. And that will make all the difference. Still do the math. If you think it's going to be $34.50, that doesn't even make sense. It doesn't even cost her $1 to drive a mile. So it can't be more than $6. It cannot be more than $6. In fact, it's a piece, 0.575, of 6. So I'm going to move the decimal 3 times. Do you need that 0? Nope. Whew, what does it cost her? $3.45. Wow. It will cost her $3. Her name's Anne, I'm going to say it. for a week. It will cost Anne $3.45 for a week. Oh man, that was a really complicated and awesome learning experience there. I hope you made that mistake and went on that journey with me. I think we learned so much from mistakes. Will you take these numbers, 24, 25, 26, and glue them in your journal in a place where it's not going to cover up any of the holes? So I'm actually going to trim off a little because I can without cutting off any of my hard work. And then I'm going to get it in a place that's not going to cover any of the holes. Will you please do that as well? Try to get it done quickly. Push pause on the video if I move on before you're ready. But this is a long journal video today, so I hope you can go pretty quickly. And the next thing we're going to do, I know you thought we were done. You thought we were done. We're not. We're really close though. The next thing we're going to do, I asked you to save some really cool pieces. Will you take the pieces that you saved from before and flip it back over and cut out numbers 1 through 8, but keep all of the instructions. And keep the practice with decimals heading. I'll show you in just a minute what it looks like. You can throw all the rest of the scraps in the garbage. Okay, it says practice with decimals. This is what I did. I love this. It says, suppose you know that 23 times 48 is 1,104. Use this to find each product. So guess what? They only used the numbers 23 and 48. They just represented them in different place values. So I know in every single answer, there's going to be a 1, 1, 0, 4. So I'm just going to go do all of those on each line right now. The only thing that changed was where the decimals were. Look, the digits had just done a bunch of shifting. So I love this. I love it so much. Come to the end of each one and put a decimal box by it. Just so I can make sure. Ooh, on these ones, we're going to put the decimal. Yeah, same thing. It's fine. And let's make our decimal boxes green. We've been doing green the whole time. I promise this is the last thing we're doing. Good job hanging in there. In fact, if you're paying attention and you hear this message, since you've hung in there, you can come see me and everyone's going to get a treat from drawer 5. But you have to come see me right after you're done with the math journal video. Hope you got it. Okay, so I have all these green decimal boxes. I have the right digits. I just need to know where the decimal goes. It's pretty easy if you look at it. So look at number 1. 23 doesn't have a decimal, but 4.8, there is a decimal. How many digits are after the decimal in 4.8? 1. So a 1 goes in the decimal box. Which means when I get to the answer, 1104, I'm going to move the decimal. It would be here at the end of 4. I'm going to move it one place to the left. Because after we've done multiplying, that's what we've been doing. We've been moving the decimal to the left when we get done multiplying. So it's 110.4. Did that make sense? 23 times 4 plus some more. Yeah, it's almost like 25 times 4. That'd be 100. So yeah, this is correct. 110.4. Number 2. Actually, let's go down first. So number 3. What's the number that goes in the decimal box? It should be a 2. Show me that on the numbers. 1, 2. Number 5. Oh, so we got to actually do it. Move the decimal 2 places. It should be 11.04. Is that about right? 2 times about 5? Yeah. 48 times 2. This is going to be a little bit bigger. And I've got 1 decimal place. 110. 48 times 2 is about 50 times 2, which is about 100, and some more. Awesome. The next one, how many decimals are in Number 7. Do you get what I'm doing here? Why don't you try all of the right-hand side on your own? Put the number in the decimal box, move it that many times, make sure the answer makes sense, and circle it. Then check your work. I'm going to freeze it. Good luck. It didn't want to freeze. Still doesn't want to. You luckies. Just get ahead of me. Ooh. Number 2 is interesting. Could that make sense? Could a piece of 4 be 1? Yep. Ooh, a piece of 2. Yeah, a piece of 2 could be 1. 4 times 2 is about 8. Plus some more. Oh, it will be 5 times 2. See, I'm thinking out loud. Do you love that or what? A piece of 48. Yeah. Crazy. Decimal placement is so important. Let's go ahead and write that. Well, let's slide this down a little in our journal. Check all of your answers here. 1.104, 1.104, 11.04, and 11.104. 11.04, sorry. Okay, so we're going to write at the very bottom, decimal placement is important. Put a big old exclamation point after that. Put some green underlines, some yellow dashes. We are done with our journal, finally, for today. You hung in there really long. I'm really proud of you. Hopefully you got a really good review. Today, I'm going to let you skip. Oh, I hope you're listening. Today, I'm going to let you skip Think Central for today. You might have to do it later, but for today, you can skip Think Central. So lucky. Because you have a homework and remembering page to work on. Yeah, you still have to do the homework and remembering, but I'm letting you skip Think Central. So have so much fun with homework and remembering. You can do this. I know you can. Right? You got this. Actually, I hope you watched the very end of the video. That's all I'm going to say. If I have written it on the planner board as something different, after you see this part in the video, someone's going to have to come and remind me that I let you do that on remembering. Peace out. Thanks for hanging in there.